All right, guys, here are our section 5.2 notes. So now we're going to talk about division with exponents and what that looks like. So a quick tip, if we add exponents when we multiply, there's probably a chance that when we divide exponents, we subtract somewhere. All right, so let me just show you what that looks like. So first, we have to talk about negative exponents. So if a does not equal 0 and n is a positive integer, then if we have a to the negative nth power, that is the exact same thing as saying 1 over a to the n. Okay, so we move things with the negative exponents to the opposite side of the fraction to make the exponent positive. Okay, so if we have a to the negative n, and that's 1 over a to the n, if I'm given 1 over a to the negative n, and I just told you guys we need to switch it to the opposite side to make it positive, that's the same thing as a to the n. What is on my finger? That's weird. Okay. And so these are actually really, really important. And a very important concept. Okay, so let's look at our examples. All right, so we have 6 full examples for you today. All right, so we have 2 to the negative third power. So it's a negative exponent, so I need to, if this was over 1, I need to move it to the bottom. Okay, so that's the same thing as 1 over 2 cubed. Well, 1 over 2 cubed is the same thing as 1/8. Okay? So we have negative 5 to the negative 2 power. Oh, I know what that is. All right, so negative 5 to the negative 2 power is the same thing as 1 over negative 5 squared. Okay? And that's 1 over 25. Okay, so looking at number 3. Number 3 is completely different from number 2. Remember, the exponent only stays with what's directly to the left of it. So if I put this over 1, it's going to go to the bottom, right? So what part goes to the bottom? Just the 5, because it's the thing directly to the left. So that negative is going to stay on top, and it's going to become a negative 1 over 5 squared. So it becomes negative 1 over 25. You see how there's a difference there? Okay. So remember, the exponent only has to deal with what's directly to the left, which means in example 4, this negative 6 only applies to the x. So the 3 stays on top. The x goes on the bottom. Okay, now in this case it applies to everything. So we have 1 over 3x to the 6. Now this goes back to our last set of notes, okay? This is product of powers. So we have 2 things inside of the parentheses. We have an exponent on the outside. So everything inside the parentheses gets the exponent, including the 3. So it becomes 1 over 3 to the 6, x to the 6. Okay? And if you put 3 to the 6th in the calculator, you get 1 over 729 x to the 6th power. Okay. Looking at number 6, we very much could take that x to the 5th and put it in the denominator, but right now they're being multiplied. And in our last set of notes, we talked about if they're being multiplied, all we have to do is add our exponents. So we have x to the 3 plus negative 5, which is the same thing as x to the negative 2. So because my exponent still ended up negative, I'm still going to move it to the denominator. 1 over x squared. Okay? So that's the main gist with negative exponents. So we can't actually have a negative exponent, so our goal is to always make it positive. So if that means flipping it from one side of the fraction to the other, then that's what we have to do. All right? So looking at property 4 of exponents, if we have a to the m power divided by a to the n power, remember I told you if we're dividing, we're probably subtracting somewhere. So we're going to take a to the m minus n. All right, and that's the same thing, top minus bottom. Okay, now remember your bases have to match. If the bases don't match, you can't do this. All right, so when dividing, you subtract the exponents on the like bases. Okay, and it has to be like bases. If it's not, you can't do it. So I'm trying to find more colorful pens to potentially do some of our next problems. Okay, this might be too close. We'll use that one. Hopefully that works. All right, so let's look at number 7. Okay, so we have x to the 9th divided by x to the 6th. So this is an example of just top minus bottom. The bases are the same. So we have x to the 9 minus 6, which is x cubed. Okay, pretty self-explanatory. All right, so let's go ahead and look at number 8. The bases are the same, so no matter what, I can do what I need to do. All right, so x to the top minus the bottom. So notice how I kept the minus sign there, and I put the -4 in parentheses. Okay, which would give me x to the -6. But we can't actually have a negative exponent. So going back to our first couple of examples, because we have that negative exponent, it goes to the denominator. So it's 1 over x to the 6th. Okay. Looking at number 9. So the first thing I noticed about number 9 is we have 5x, 5x. Okay, they're the same thing, so I'm not really going to play around with it just yet. All right, so I'm going to leave it until we've played with our exponents first. Remember, please excuse my dear Aunt Sally. So we have to do what's inside the parentheses first, but there's nothing to do inside the parentheses, so I move on to exponents. All right, so I see I have 5x to the 5th divided by 5x cubed. So what I'm going to do is I'm going to go ahead and subtract my exponent. So we have 5x 5 minus 3, which is 5x squared. And you'll notice I left the 5x inside the parentheses because that's how it was written. Okay, and I don't want to change it. But now we have a product of powers, a power of a product. So everything inside the parentheses is going to be squared. Okay, so I'm going to square everything. So this becomes 5 squared, x squared. 5 squared is the same thing as 25, x squared. Okay. And number 10. First thing I notice is on the bottom we have 2x in parentheses, and on the top we don't. So I'm going to put that 2x on the top in parentheses. I also noticed that there's no exponent on the top. Or is there? So if there's no exponent that's listed, it's always the imaginary 1. Okay? The unwritten 1. Okay? So we're still going to subtract. So we have 2x 1 minus 4, top minus bottom. So we get 2x to the 3. It's negative, you got to make it positive, so we flip it to the denominator. 1 over 2x cubed. All right, so we still go back to our power of a product. Everything gets cubed. Okay, so we have 1 over 2 cubed, x cubed. 2 cubed is 8, so we have 1 over 8x cubed. All right? Pretty self-explanatory. Cool. Property number 5, we have, this is the quotient to a power. So just like we had the product of a power where we had two things multiplied inside the parentheses, the quotient to a power is two things are being divided inside the parentheses, which all this tells me is that everything still gets the exponent that's on the outside. Okay, as long as there's no addition or subtraction, because that's key, everything gets the exponent. All right, so looking at 11, there's no addition or subtraction, there's only division. Everything gets the exponent, so we get x cubed over 2 cubed, and we know that 2 cubed is 8. Okay. Looking at 12, everything still gets that exponent. Everything gets squared. So we have 3 squared over 5 squared, which is 9 over 25. Okay. So there's a couple of different ways we could do this next one. I'm going to show you what I think is the easiest way to do it. I see on the inside of the parentheses that we have a division problem with exponents. Based off of PEMDAS, I have to do what's inside the parentheses first. So I'm going to take, so how do I want to rewrite this? Y to the 3 minus 5 to the 4th, because that's still there. That becomes y to the negative 2 to the 4th. Okay. Which becomes y to the negative 8. Because it's a negative exponent, I need to change it. So 1 over y to the 8. Okay. All right. And let's look at 14. First thing I notice about 14, because it's a little different, is I have an x on top and an x on the bottom. Okay. So we have to do what's inside the parentheses first. So I'm going to take x to the 6 minus 3 over y squared. There's still a squared on the outside, but I have to do what's inside the parentheses first. So I get x cubed over y squared, still squared. So I have to square everything. So I have to multiply by 2 to everything inside the parentheses. So I get an x to the 6, y to the 4. Yeah. Cool. What's on the back? What do we got on the back? Okay. Last kind of trick. All right. Because a lot of, well, actually, that's a lie. We have scientific notation. But this is how a lot of people try and trick people. So if our base doesn't equal 0, so it equals some number somehow. If we have any base to the 1 power, it equals a, no matter what. You could have 1 million to the first power, and it's going to equal 1 million. Okay? So anything to the power of 1 is equal to itself. However, anything to the 0 power is going to equal 1. Why? To be honest, I don't know. So let me research that and I'll get back to you on that. Okay? So let's look at our guided practice here. So 8 to the 0, anything to the 0 power is 1. Anything to the first power is itself. So looking at 17, where we actually have a combination, anything to the 0 power is 1. Anything to the first power is itself. 1 plus 4 is 5. Put boxes around my answers so you can see. Looking at this one, anything to the 0 power. Even if it's a combination of crazy things looking like this, it's still going to be 1. Every single time. Aww. I got a notification that my daughter just had blueberry muffins. Oh, that's so cute. All right. Mixed practice. Let's look at mixed practice. Oh, and she's working on science. Okay. All right, I'm done, I promise, kind of. All right, so let's go ahead and look. First things first. Looking at question number 19, the first thing I notice is that we have like a combined thing on top. So I want to simplify what's on top before I even try to do anything with the denominator. So I notice that we have a product of powers, or power of a product, whichever way you want to. I know I'm going to be multiplying by 2, okay, because I have a squared here, and I want to square everything on the top. All right, so I'm going to end up with a 5 squared and an x cubed, and I want to square it. My denominator stays the same, x to the 4th. So that new numerator becomes 25 x to the 6 over x to the 4th. So I'm dividing by x to the 4th. So there's no coefficients on the bottom. So because there's no coefficients on the bottom, I know 25 is going to hang out there. But I have this x to the 6 divided by x to the 4th. That's going to be x to the 6 minus 4. So the 25 stays the same. 6 minus 4 is 2, so we have 25x squared. Okay. First thing I'm going to do with number 20 is I'm going to simplify the bottom. So we have x to the negative 8 divided by x to the 6. Okay. From here, there's a couple of different ways we could do it, but because I see a division, that's the first thing I notice is that dividing, we're going to take x to the negative 8 minus 6 gives me x to the negative 14. We have a negative exponent. Whenever we have a negative exponent, it goes to the denominator. So 1 over x to the 14th. Just like that. Coffee. All right. 21. Again, a couple of different ways we could do this one, but I'm going to do it what I think might be the easiest way. So I see a negative exponent. That's the first thing I noticed about this problem. We can't have a negative exponent, so I'm going to go ahead and flip it right now. Grab my coffee and didn't even take a drink. So 1 over 3x to the 5th, and that 2 becomes positive. Okay? So now we have power, product to a power, power to a product, something like that. Everything inside gets squared or multiplied by 2 if it has an exponent. So we have 1 over 3 squared x to the 10th. Okay, 3 squared is 9, so we have 1 over 9 x to the 10th power. Right? 3 squared is 9. Yes, okay. It's been a while. All right, 22. Let's just simplify. And when I say simplify, I mean let's get rid of the parentheses. So first thing I'm going to do, product to a power. Power to a product, whatever. So we have a to the 6th times a to the 4th, or negative 4, sorry, over a to the negative 12. Okay, let's go ahead and simplify the numerator. There are 2 bases here. They're both a's. So I can add those together. So we have a to the 6 plus negative 4 over a to the negative 12. 6 plus negative 4 is 2. So a squared over a to the 12. We're dividing. So we have a to the 2 minus 12, top minus bottom, equals a to the negative 10. We have a negative exponent, yeah? Oh, y'all, brain fart. That's my fault. Where's my whiteout? So I forgot that the denominator is a negative 12. So because, oh, come on. Because it's a negative 12, whenever we minus a negative, so this should be 2 minus negative 12. 2 minus negative 12, if we minus the negative, it's a positive. So 2 minus negative 12 is positive 14. There we go. That looks better. That's our final answer. Okay. So moving on to scientific notation. In scientific notation, large numbers are going to have positive exponents. Small numbers, ones that are less than 1, are going to have negative exponents. Okay, so remember from our last set of notes, it's going to be some number. Well, when we're writing in scientific notation, it's going to be some number times 10 to some exponent. Okay, so I'm going to do 24 first. So right now, 24 is written in expanded form. So this 0.00688 is extended form. We want it in scientific notation, so I want to shorten it up, which means I want to move the decimal between the 6 and the 8, the first 8. So because this number right here is already smaller than 1, I know that my exponent is going to be negative. Okay, so I'm going to go ahead and count from where the decimal is to where it should be. 1, 2, 3. So I know it's going to be negative 3. So it should be 6.88. And that's my final answer for 24. 23, I need to turn it into expanded form, which means there's no times 10, there's no exponent, any of that. So I'm going to take this 5.7, and because my exponent is a negative 4, that means I'm moving to the left. So I want this number, once I multiply, or once I move the decimal 4 places, it has to be smaller than 1. So I'm going to move it to the left, 1, 2, 3, 4, which means I have 1, 2, 3 zeros. So my answer to 23 is 0.00057. Okay. I hope that made sense. If you have any questions, let me know.